Moving on to question 3b. Describe fully the single geometrical transformation P represented by the matrix B. Okay, so now what I will write is this. Okay, so I have transformation and then represented by which matrix? So what we have here, transformation P matrix B. Let's take a look at question B. So matrix B is equal to -1, 0, 0, 1. So we have values over here. So this will represent our X element and this will represent our Y element. So X you will multiply by -1, which you will get -X. Whereas your Y you will multiply by just 1, which is maintained as Y. What type of transformation that transform X to -X but maintain the Y? This is reflection by the Y-axis. That's it. That is for question B. Now, transformation Q is represented by the matrix A to the power of N. Okay. Transformation P is followed. Okay, so for question C, transformation P is followed by transformation Q. This is what we call transformation R. So we have the next transformation R. And what is R? R is, we begins by P and then we have Q. Transformation R is represented by matrix C. So transformation R, what's the matrix? The matrix is C. So what we have to be very careful is we have to distinguish between the transformation and also the matrix. Okay. Now let's take a look what they want us to find. Okay, they want us to find C in terms of N. Okay, so what we want to find? We want to find matrix C. Okay, in terms of N. Okay, so let's take a look. We have transformation P and then followed by Q. So this is transformation. Now, what is the matrix? You have to know that transformation and matrix will work in inverse way. So, if we have P first for the transformation, okay, and then Q second for the transformation. So, this one first and this one second. For our matrix, it will be the other way around. So, this one will be first and this one will be second. So, matrix, it will be A to the power of N. We will write that one first and then B. That's it. So, that is C. A to the power of N, B. What is A to the power of N? A to the power of N is 1, 0, 5, open bracket, 2 to the power of N minus 1, close bracket, 2 to the power of N. Let's multiply by B, -1, 0, 0, 1. Let's do our matrix multiplication. Let's consider first matrix, first row, second matrix, first column. Okay. So let's write down the element from the first matrix. So 1, give it a bit of space, plus 5, open bracket, 2 to the power of N minus 1. Let's consider the elements from the second matrix. It will be -1 here, 0 here. Okay. we will maintain the column from the second matrix, but we will consider the second row for the first matrix. So this one, okay, let's write down the elements from the first matrix. 0, give it a bit of space, plus 2 to the power of n. Second matrix, okay, the first bracket will be -1. The second bracket will be 0. Now, next element, we will consider first matrix, first row, second matrix, second column. Okay. Elements from the first matrix, 1. Give it a bit of space, plus 5, open bracket, 2 to the power of n minus 1. Now, elements from the second matrix, first bracket would be 0, second bracket would be 1. Okay, we will consider first matrix, second row, second matrix, second column. So this would be, okay, let's begin with the elements from the first matrix, 0 plus 2 to the power of n. Okay, the elements from the second matrix, open bracket 0, open bracket 1. So let's simplify all of this. 1 multiplied by -1 would be -1. Anything multiplied by 0 would be 0. Here would be 0 plus 0. Here would be 0 plus 5, open bracket, 2 to the power of n minus 1. Here would be 0 plus 2 to the power of n. This one would be -1, 0, 5, open bracket, 2 to the power of n minus 1, and 2 to the power of n. With that, we are done with question C. Let's take a look at D. Given that for a particular value of n, the transformation R maps the point with coordinate 27, 1 to the point with coordinates A, where A is constant. Determine the matrix that represent transformation Q. Okay, so what we want to find, okay, we want to find matrix that represent transformation Q. So matrix that represent transformation Q, we want to find what is A to the power of n. But what is the information? We know that, okay, point 27, 1, if we performed transformation R, we will get coordinates A. Okay, transformation R, what is the matrix? The matrix is C from our part C. So how can we proceed with this question? So it would be AA, okay, the image is equal to matrix C, which is -1, 0, 5, open bracket, 2 to the power of n minus 1, 2 to the power of n, okay, multiply with the original coordinate, 27, 1, equal to, let's perform matrix multiplication. So this multiply by this. So this time, okay, let's consider the first row. So we'll have -1, give it a bit of space, plus 5, open bracket, 2 to the power of n minus 1. Consider the elements from the second matrix, 27 and 1. Moving on to the second row for our first matrix. Okay, that would be 0, give it a bit of space, plus 2 to the power of n. Now, the elements from the second matrix, 27 and 1. Let's simplify our matrix. We will get -27 plus 5, open bracket, 2 to the power of n minus 1. And then here would be 0 plus 2 to the power of n. We can still expand and simplify the first row. So here would be -27 plus 5, open bracket, 2 to the power of n, close bracket, minus 5. Okay, this one would be 2 to the power of n. Okay, so what we have is this. AA is equal to, okay, negative 27 minus 5, which is 5 bracket 2 to the power of n minus 32, and this is 2 to the power of n. By looking at this, okay, let's name this row. Okay, equation 1. Oops. Equation 1, and this is equation 2. So what is equation 1? Equation 1 is 5 2 to the power of n minus 32 is equals to a. Equation of 2, okay, I have 2 to the power of n equals to a. So substitution method will be the easiest for this question. So we will sub equation 2 into 1. So we will get, okay, 5. This is 2 to the power of n is a. Okay, minus 32 equals to a. If I rearrange, I will get 5a minus a, that will be 4a equals to 32. A is equal to 8. Let's substitute back into this. So sub a equals to 8 into equation 2. So we will get 8 is equal to 2 to the power of n, which is equal to 2 to the power of 3. Therefore, n is equal to 3. Okay, now that we know the value of n, which is 3, we can find a to the power of n. Okay, so what is a to the power of, a to the power of 3. So this is equal to 1, 0, 5, open bracket, 2 to the power of 3 minus 1 and 2 to the power of 3. This is equal to 1, 0, 5, open bracket, 2 cubed minus 1. That is equal to 35. And over here we have 2 cubed. That is 8. With that, we are done with part D.